To me, Iron Man is good science fiction. Good science fiction in one sense. Every great science fiction story always starts with premise. Some technology or group of technologies that may not exist today probably can't exist today, and it builds a story around it. It doesn't have to explain how it can be made or why, just that it exists and the social and economic implications that in the story are explored. Because science fiction is always about telling about the future, what could happen based on today and the past, what has happened. I love superhero stories in general because they're topical, but my favorite superhero of all time is Iron Man because he's one of the few superheroes that has no actual superpowers. Sure, Batman's cool, he can fight and shoot grappling hooks, but Iron Man's suit is a far greater technological marvel, no pun intended, than the Bat suit. And so many people want to know, how can you become Iron Man? Believe it or not, many aspects of the suit actually are real. There are lasers, there are particle beams. We can create lasers, we can create particle beams, we can create rockets, we can create exoskeletons and spacesuits and sensors and computers. All of these things can and have been invented. The problem is miniaturization, a power supply. You need a power supply to run all of these things. And in the movies, what Stark makes his power supply, he calls it an arc reactor. And he states that the energy output of it is 3 gigajoules per second, which is roughly 3 times the power output of a large scale commercial nuclear reactor. Now, that is an enormous amount of energy, but believe it or not, there are real fuel sources right now that indeed have that energy density. They fall under the umbrella term of nuclear power. Nuclear power refers to unlocking the power of the nucleus, where protons and neutrons exist in atoms. The energy release from nuclear reactions is roughly a million times greater than the energy release from chemical reactions. The type of power plants we have now are fission ones, and we've had those for about 50 years. But a fission reactor is not what Tony Stark has made. What the movie implies an arc reactor is the next step up, a fusion reactor. A fusion reactor is something that takes light atoms, and smashes them together, releasing energy. It's a great energy source. This is what happens in the sun and stars, providing all of their light. Scientists have been working on this idea for 60 years, and they haven't been able to make a working fusion reactor yet. Now, the machines that produce fusion reactions, they're enormous. They're the size of skyscrapers, and they cost tens of billions of dollars to build. They're basically like aircraft carriers. They have the size and cost of an aircraft carrier. So what happens in the movie is Stark in a cave with a box of scraps manages to make an arc reactor, one that's small enough that fits in his chest. So there are two things to look at this. Two things when looking at the arc reactor. The first is, does fusion actually have the energy density to do that? And the answer is yes. The type of fusion that scientists have been working on deals with a fuel called deuterium and tritium, and its energy density is 350 terajoules or 350,000 gigajoules per kilogram. It would take about zero point zero 0.08 grams of DT fuel to produce 3 gigajoules of energy. So we know fusion has that energy density. Then this now the second big problem is, can you make a fusion reactor as small as the one that fits in his chest? Well, yes and no. Currently, no. The machines that generate this require far too much power and produce far too much waste heat to be anywhere near that small. And if you did make it that small, the waste heat from the device initiating a fusion reaction would vaporize the reactor in half a second. However, there's another way of generating fusion that doesn't happen on Earth. On Earth, we use high powered lasers and magnets, but the stars use something else, gravity. Gravity, although it is an enormously weak force, is attractive and is fully capable of confining a very hot plasma, which consists of the fusion fuel, for an almost indefinite amount of time, allowing for almost, well, in the case of the sun, self-sustaining fusion reactions to occur. This is how the sun and other stars shine, and it's what holds stars together, this gravity, and it's gravity alone. The inward gravitational pressure causes sustained fusion reactions. These fusion reactions produce an outward thermal pressure, but the two pressures are canceled out, allowing the plasma to be held together and remain stable. And as you all know, the sun is enormous. It just has over 1 million times greater mass than that of the Earth. And thus, since there isn't anywhere near enough matter on Earth, gravitational confinement on Earth just cannot happen. And we have no idea how to create artificial gravity fields either. But assuming we somehow could create artificial gravity fields, then we would be able to create a working fusion reactor. And it could be as small as the one Iron Man has built, one that's the size of a hockey puck. Now, keep in mind, although producing 3 gigajoules per second would be possible, any type of machine you build is not going to be anywhere near 100% efficient when it comes to producing electricity. The waste heat from such a device, even if it was 99% efficient, would instantly kill Tony. It would roast him alive. But it does build on the premise of a working fusion reactor, a nuclear reactor. And yes, one day we may have a working fusion reactor, or we may not. But unless we figure out a way to control gravity, it'll never be this small. In fact, a working fusion reactor may not exist at all, ever. But yes, once you have the arc reactor, the power supply that he makes, then the Iron Man suit becomes practical. 3 gigajoules per second for a hockey puck sized device. That's more than enough energy for rockets, lasers, particle beams, exoskeletons to do all of the things he sees in the film. Lifting buildings, punching through concrete walls, uh, flying into outer space, crossing continents in hours, so on and so forth. So once you make the exemption, once you can figure out how to make a good enough power supply, you have the Iron Man suit. And the films do a great job of exploring the implications of that.